Welcome dear audience, students and scholars. Here I'm Dr. Amjad Ali. In this video we will learn about the golden rule level of capital. Dear scholars, so far as we have used this shallow model to examine how an economy's rate of saving and investment determines a steady state levels of capital and income. This analysis might lead you to think that higher saving is always a good thing because it always leads to greater income. Yet suppose a nation had a saving rate of 100% that would lead to the largest possible capital stock and largest possible income. But if all of this income is saved and none is ever consumed, what good is it? In this video, we use the shallow model to discuss the optimal amount of capital accumulation from the standpoint of economic well-being. Comparing the steady states, to keep the analysis simple, let's assume that a policymaker can set the economy's saving rate at any level. Okay, by setting the saving rate, the policymaker determines the economy's steady states. Now, one of the main question arises here that what steady state should the policymaker choose? The policymaker's goal is to maximize the well-being of the individuals who make up the society. Individuals themselves do not care about the amount of capital in the economy or even the amount of output. They care about the amount of goods and services they can consume. Okay, that's a prominent policymaker would want to choose the steady state with the highest level of consumption. The steady state value of K that maximize consumption is called the golden rule level of capital and is denoted by K steric gold. Now, one of the main question arises here that how can one tell whether an economy is at the golden rule level? Okay, to answer this question, first determine steady state consumption per worker, then see which steady states provides the most consumption. Okay, to find the steady state consumption per worker, we begin with the national income account identity. Per worker, we have Y is equal to C plus I, and rearrange it as we have C is equal to Y minus I. Consumption is output minus investment. Because we want to find steady state consumption, we substitute steady state values for output and investment. So steady state output per worker is FK static, where K static is the steady state capital stock per worker. Okay, furthermore, because this capital stock is not changing in the steady state, investment equals depreciation, we have delta K static. Okay, substituting FK static for Y and delta K static for I, it can be written steady state consumption per worker as we have C static is equal to FK static minus delta K static. According to this equation, steady state consumption is what left of steady state output after paying for steady state depreciation. This equation shows that an increase in steady state capital has two opposing effects on steady state consumption. On the one hand, more capital means more output. On the other hand, more capital also means that more output must be used to replace capital that is wear out. So let's see a graphical presentation. How can we achieve steady state consumption? Okay, we have steady state capital per worker on x-axis, and we have steady state output and depreciation on y-axis, and we have steady state depreciation and investment delta K static, and we have steady state output FK static, and here we have the difference between steady state output and depreciation is our C static gold. and we can say that steady state consumption, and we have one golden rule level of capital, K static gold, and below that point the golden rule steady state increase in steady state capital raises steady state consumption, and above that the golden rule steady state increases in steady state capital reduces steady state consumption. So this graph presents as steady state output and steady state depreciation as a function of steady state capital. So steady state consumption is the gap between output and depreciation. This figure shows that there is only one level of golden rule capital K static that maximize the consumption. When comparing steady state, we must keep in mind that higher level of capital affects both output and depreciation. If capital stock is below the golden rule level, an increase in the capital stock raises output more than the depreciation, so consumption rises. In this case, the production function is steeper than the delta K static line, so the gap between two curves which equal consumption grows as K static rises. By contrast, if the capital stock is above, we can say that on this level, an increase in the capital stock reduces consumption because the increase in output is smaller than the increase in depreciation. In this case, the production function is flatter than delta K static line, so the gap between the curves consumption shrink as K static rises. As at the golden rule level of capital, the production function and the delta K static lines have the same slope and consumption is at greatest level. So we can conclude this graph that the economy's output is used for consumption or investment. In the steady state, investment equals depreciation. Therefore, we have here in the steady state consumption, we have the difference between the depreciation and output. So steady state consumption is maximized at the golden rule state. The golden rule capital stock is denoted here by a K static gold, and the golden rule of consumption is denoted by a C static gold. Okay, now derive a simple condition that characterize the golden rule level of capital. Okay, now derive a simple condition that characterizes the golden rule level of capital. Recall that the slope of the production function is the marginal product of capital MPK. The slope of the delta K static line is delta. Because these two slopes are equal at K static gold, we can say that the golden rule is described by the equation MPK is equal to delta. Okay, at the golden rule level of capital, the marginal product of capital equals the depreciation. Okay, to make the point somewhat differently, suppose that economy start at some steady state capital stock K static, and that the policymaker is considering increasing the capital stock to K static plus 1. Okay, the amount of extra output from this increase in capital would be Fk static plus 1 minus Fk static, the marginal product of capital MPK. The amount of extra depreciation from having one more unit of capital is the depreciation rate delta, here delta. Okay, thus the net effect of this extra unit of capital on consumption is MPK minus delta. If MPK minus delta is greater than 0, then increase in capital increase consumption, so K** must be below the golden rule level. Okay, if MPK minus delta is less than 0, then increases the capital decreases consumption, so K** must be above the golden rule level. Okay, therefore the following condition describes the golden rule here: MPK minus delta is equal to 0. So at the golden rule level of capital, the marginal product of capital net of depreciation MPK minus delta is equal to 0. As we will see, that policymaker can use this condition to find the golden rule capital for an economy. Okay, keep it in mind that economy does not automatically deviate toward the golden rule steady state. If you want any particular steady state capital such as golden rule, we need a particular saving rate to support it. So let's see a graphical presentation how the saving rate and golden rule can achieve. So here we have saving rate and the golden rule in the graphical shape. We have steady state capital per worker, K** on x-axis, and we have steady state output depreciation and investment per worker on y-axis, and we have a steady state depreciation and investment. We have delta K**, and here we have saving, gold saving FK*, and we have output FK*, steady state output FK*, and we know the golden rule of consumption, the difference between the depreciation and output. We have C gold static, and at this point we have K* gold here. So here we have this amount of investment I* gold, and here we have K* gold. So here keep it in mind, to reach the golden rule steady state, here the economy needs the right saving rate. So this figure shows that the steady state, if the saving rate is set to produce the golden rule level of capital, if the saving rate is higher, the one used in this figure, the steady state capital will be too high. If the saving rate is low, the steady state capital stock will be too low. In either case, the steady state consumption will be lower, because we are here considering the difference between the depreciation and output as a consumption. So we have a lower level of consumption in either case, that on the steady state golden rule here. Okay, now we are moving towards the transition to the golden rule steady state. Okay, let's now make the policy makers problem more realistic. So far as we have assumed that policy maker can simply choose the economy steady state and jump there immediately. In this case, the policy maker would choose the steady state with the highest consumption, the golden rule steady state. Okay, now suppose that the economy has reached a steady state other than the golden rule. Okay, now we have the main question here, that what happens to consumption, investment and capital when the economy makes the transition between the steady state situations. And we have another question, that might the impact of the transition deter the policymaker from trying to achieve the golden rule. Okay, it must consider two cases. Here, the economy might begin with more capital than in the golden rule steady state or with less. It turns out that two cases offer very different problem for the policymakers. Okay, as we have discussed in our previous session as well. Okay, starting with too much capital. Okay, first consider the case in which the economy begins at a steady state with more capital than it would have in the golden rule steady state. In this case, the policymaker should pursue policies aimed at reducing the rate of saving in order to reduce capital stock. Suppose that these policies succeed at that and at some point, call it time t naught, the saving rate falls to the level at that will eventually lead to the golden rule steady state. Okay, let's see a graphical presentation that how we have too much capital work here. Okay, we have here time on x-axis, and we have steady state output route, and we have steady state consumption, and we have steady state investment, and we have t time. Actually, we are here discussing that reducing saving when starting with more capital than in the golden rule steady state. Okay, when we reduces the saving, reduce in saving will eventually increase the consumption level and reduces the output, and that will reduces the level of investment in the economy. Now we discuss that what actual happens here. This figure shows that what happens to output, consumption and investment when saving rate falls. The reduction in saving causes the immediate increase in consumption and decreases in investment. Because investment and depreciation were equal in the initial steady state, investment will now be less than depreciation, which means the economy is no longer in a steady state. Gradually, the capital stock will fall, leads to reduction in output. Consumption and investment will also fall. These variables continue to fall until the economy reach a new steady state level, because we are assuming that new steady state is the golden rule steady state. Consumption must be higher than it was before the change in saving rate, even though output and investment are lower. Okay, note that when you compared the old steady state consumption with the new steady state consumption, we have an entire new path here. When capital stock exceeds the golden rule level, reducing saving is clearly a good policy, for it increases the consumption at every point in time. Okay, now we are starting with too little capital. Let's see our graphical presentation here. First, increasing saving when starting with less capital than in golden rule steady state. We have here time on x-axis, and we have a steady state output, we have steady state consumption, and we have steady state investment. Okay, when the economy begins with less capital than in the golden rule steady state, the policymaker must raise the saving rate to reach the golden rule. So here we have time, and the policymaker want to increase the saving rate. Okay, by increasing the saving rate, we have higher amount of output, and we have the higher amount of consumption. By increasing the saving rate, first see here we have a reduction in the consumption, but in the long run this consumption will rise. So let's see this figure shows that what happened, the increase in saving rate at T naught causes an immediate fall. Here see immediate fall in consumption and rises our investment level in the economy. Over the time, higher investment causes the capital stock to rise as capital accumulates. Output and consumption and investment gradually and eventually rising and reaching a new steady state level. Because the initial steady state was below the golden rule, the increase in saving eventually leads to a higher level of consumption than which was prevail at initial level. Okay, this figure shows that output, consumption and investment react with one and with any change in the saving when the economy begins with less capital than the golden rule level and the saving rate is increased. The increase in saving at time T naught causes an immediate drop in consumption here and an equal jump in investment. Moreover, over the time, as the capital stock grows, output and consumption both, and as well as investment altogether will increase because the economy begins with less capital than the golden rule. The new steady state has a higher level of consumption than its initial steady state. Okay, does the increase in saving that leads to the golden rule steady state raises economy's welfare? One of the main question here that eventually it does, because the new steady state level of consumption is higher than the initial level, but achieving that new steady state requires an initial period of reduced consumption. Note that the constant consumption will prevail. Moreover, the contrast to the case in which the economy begins above the golden rule. So when the economy begins above the golden rule, reaching the golden rule produce higher consumption at all points in time. When the economy begins below the golden rule, reaching the golden rule requires initially reducing consumption to increase consumption in the future. When deciding whether to try to reach the golden rule steady state, policymakers have to take into account that the current consumer and the future consumers are not always the same people. Reaching the golden rule achieves the highest steady state level of consumption and thus benefits future generation. But when the economy is initially below the golden rule, reaching the golden rule require raising investment and thus loading the consumption of current generation. Thus, when choosing whether to increase capital accumulation, the policymakers face a trade-off among the welfare of different generation. A policymaker who cares more about current generation than about future one may decide not to pursue policy to reach the golden rule steady state. By contrast, a policymaker who cares about all generation equally will choose to reach the golden rule, even though current generation will consume less at initial level. An infinite number of future generation will benefit by moving to the golden rule. Thus, optimal capital accumulation depends crucially on how we weigh the interests of current and future generation. The golden rule tell us does unto others as you would have them to do unto you. If we heed this advice, we give all generation equal weight. In this case, it is optimal to reach the golden rule level of capital, which is why it is called the golden rule. So this is all about the golden rule of capital and the solo growth model. So see you with another video. Ciao.